An igloo is made of snow. Snow is frozen water. Frozen water is cold. So logically, a house made of snow should drain heat from your body faster than almost anything else. Yet people have survived entire Arctic winters inside igloos, while temperatures outside were cold enough to kill in minutes. So the question isn't what an igloo does. The real question is, how does it stop heat from escaping? To understand igloos, you need to understand heat loss. Your body loses heat in 4 ways. Conduction, heat moving through materials. Convection, heat carried away by moving air. Radiation, infrared energy leaving your body. Evaporation, heat lost through moisture. An igloo is designed to slow all 4 at once. That's why it works. Conduction depends on how tightly packed a material is. Metals conduct heat well because atoms are tightly bonded. Air conducts heat poorly because molecules are far apart. Snow is mostly air. A typical snow block used in an igloo contains thin ice crystal frameworks, large volumes of trapped, motionless air. When heat tries to escape through the wall, it moves from warm air, ice crystal, trapped air, ice, air, ice. Each transition slows energy transfer. This is why animals burrow into snowbanks. Snow shelters can be warmer than tents. Ski clothing uses trapped air, not solid material. The igloo wall forces heat to take a long, slow path outward. Pattern interrupt. The cold doesn't attack you. Your heat just can't escape fast enough. Convection is often the biggest heat killer. Warm air rises. Cold air sinks. In most shelters, warm air escapes through gaps. Cold air rushes in to replace it. Igloos prevent this using air stratification. Dome geometry. The dome causes rising warm air to collect near the top without escaping. There's no flat ceiling or corner where air pressure can push it out. Raised sleeping platform. People sleep slightly above the floor. That puts them inside the warm air layer. Sunken entrance tunnel. The entrance is lower than the main chamber. Cold air sinks into the tunnel and stays there. Warm air remains trapped inside the living space. This creates a stable convection loop with minimal heat loss. Your body constantly emits infrared radiation. In open environments, that energy disappears into space. Inside an igloo, infrared radiation hits snow walls. Snow absorbs the energy. The energy is re-emitted slowly and evenly. Snow acts like a thermal buffer. It doesn't reflect heat away instantly, and it doesn't conduct it quickly either. The result is a slow recycling of heat energy inside the structure. Evaporation removes heat very efficiently. Sweat, breath moisture, and melting snow can steal warmth fast. Igloos reduce this loss by maintaining cold, dry interior air, preventing strong airflow, allowing moisture to freeze rather than evaporate. Frozen moisture stops heat loss. Liquid moisture increases it. The igloo keeps moisture in the least dangerous state. As the interior warms slightly, thin surface layers melt microscopically. That moisture refreezes as ice. This process seals air leaks, strengthens bonds between snow blocks, reduces uncontrolled airflow. Instead of weakening, the igloo becomes more airtight and efficient. An igloo doesn't generate warmth. It slows heat loss so effectively that normal human metabolism becomes enough. It's not fighting the environment. It's cooperating with physics. And that's why a house made of snow can keep you alive.